Okay, so today someone asked me how to find the pH level using logarithms. So here is the question. Hold on, let me plug my tablet in. So in these questions, the best thing to do first is to read what it's asking for, just to make sure we have everything accounted for. So the first big thing that I'm noticing is it has an equation for us that is negative log pH is equal to negative log H plus, where H plus is the hydrogen ion concentration measured in moles per liter. Solutions with a pH value of less than 7 are acidic solutions. Solutions with a value greater than 7 are basic. Solutions with a pH value of 7, such as pure water, are neutral. Lemon juice has a pH level of 2, and tomato juice has a pH level of 4. We want to compare the pH and determine how much more acidic lemon juice is than tomato juice. So the first thing to note is, well, after reading that problem, we can identify some key pieces of information. Right here, let me highlight it in red. From here to here, this information right here isn't really needed. You don't really need to know what hydrogen ion is, or what moles are, or anything to do with liters. This part is unneeded. This is a little more relevant because we want to know which one is more acidic when we are dividing by, when we divide our values later. But it's not the most important thing. It's not really going to play into a part when we're plugging stuff in. One thing that's really important is this pH of 2 and this pH of 4. And the last important thing that we want to know is we're comparing the pH of each other, and we want to know how much more acidic lemon juice is than tomato juice. So what we want to do is we're going to use our log forms. A lot of the times in these problems, I'm not sure if the negative really needs to be worried about. Let me double check before I confirm that though. But I'm pretty sure that we do not need the negative. Give me just 1 second. Yeah, so we can treat it, the negative probably does make a difference in biology and stuff, but it makes it a little bit harder for us to be able to tell which one is going to be more acidic. And we know that since we're comparing acidity and things that are less than 7 are more acidic, we will be wanting the lower number. We'll be paying more attention to the lower number, I guess. I'll get into that more. So basically, 0 is the most acidic, and I don't remember 100%. I think it's 13 is the most basic. And the more you go this way, when you're going to the left, it gets more acidic, and when you're going more to the right, it gets more basic. We're only worried about going from right to left. So for these problems, it gives us our pH, and we can just play plug-in game at this point. We can treat H plus as an X if it makes things easier for you. We're just trying to find what number that is. So pH, one more thing to know. We're comparing two different things, so we're going to have two different equations. We'll start with lemon juice first. 2 is equal to negative log. We can just ignore the negative for now. And we'll just put an X just to make it easier. And whenever there's not a base for your log, we can assume it's 10. And that's just the rules. So we want to turn this into exponential form, so we can do 10 to the second is equal to x, which will give us 100 is equal to x. And then if we take tomato juice, we can do 4, well, let me move it up. 4 is equal to log base 10 x, which can be written as 10 to the 4th is equal to x, which is the same as 1/10,000. So then what we want to do is we want to see how much more acidic lemon juice is than tomato juice. And it's easier if we have the bigger number on top, as long as we're going from, it just is easier this way, I guess. And then 100 on the bottom, and that will bloop, bloop, give you 100. Lemon juice is 100 times more acidic than tomato juice. Yeah, the reason why we put it right here is because we know it's going to be more acidic in whole numbers, and if we have the bigger number on top, it will be a whole number. Hopefully this clears things up. I'll probably make a better video about this in the future, but this was just a quick solution as of now.